These notes are on rational equations that are proportions. So as a review, a proportion is an equation that states two ratios are equal. If the cross products are equal, the proportion is true. So for example, let's consider our first proportion. Our first ratio is 3 out of 5. Our second ratio is 6 out of 10. Right? If we multiplied top and bottom both by 2, we would get the 6 out of 10, so that we know that that's true. But another way to check this is that we can do the cross products. So cross products means multiply the top of the first by the bottom of the second. So 3 times 10. And we want to see if that's equal to the denominator of the first times the numerator of the second. So 5 times 6. And you can see that we have 30 equals 30. So that means that proportion is true. So, rational equations that are in the form of a proportion can be solved using cross products. Remember to always check for extraneous solutions. We still see that trigger, that fraction bar means division. We have to be careful that we're not causing division by zero at any step. So, to solve our first equation, we're going to find the cross products. So, 3 times 3 equal to x times x. Okay, you don't have to take this step, but I think it's good to have in your notes sometimes. So we get 9 equals x squared. So at this point, fastest way is to use the square root property. Biggest mistake when people do the square root property is that they forget if they're taking the square root of both sides and you're taking a square root of a number, you have to remember that this has a plus minus. So this would be plus or minus 3 equals x. Okay, next we're going to do a check real quick. So we're going to say is 3, let's check x equals 3 first. So is 3 over 3 equal to 3 over 3? This is obviously true, so our x equals 3 checks. Our next one, x equals negative 3. We want to see if 3 over negative 3 is equal to negative 3 over 3. So each side would be equal to negative 1, so again this checks. You do not have to write this out for the check. If you can do it as mental math, but I just wanted to show you exactly what we're doing here. So we are just putting in our answer into the original equation, making sure it's true. Now, this is a rational equation, which is different than a rational expression. So we found the solutions to these. So we just have to make sure that neither of these are exclusions to our original problem. And since the only exclusion to our original problem is x is not equal to 0, then we have our answers. X is plus or minus 3. Okay, in these you have to check for exclusions, but you do not have to write them in your final answer. There are infinitely many exclusions. Any number that isn't plus or minus 3 would need to be excluded, so we only show the numbers that are true. So for our next one, I am going to just look real quick and know that x cannot be negative 2. Okay, because if it was negative 2, I would have division by 0 and this equation would be undefined. The trick here, this is a proportion because we have one ratio equal another ratio. Sometimes the ratio here isn't obvious, but remember that you can put that as over 1. Okay, still equal, 7 over 1 is equal to 7. So the expression remains the same, and now we can solve it using cross products. So we're going to multiply 3x minus 1 this way. That's equal to 3x minus 1. And then I'm going to write this out just so that you have it in your notes. But if you wanted to do the distributive property as you find the second cross product, we have our 3x minus 1 here, and you could have gone right to the step 7x plus 14. Okay, so now we have a linear equation. Highest exponent on both sides is 1. So I'm just going to try to get x on one side and my constants on the other. So I have I'm going to move everything left. So I'm subtracting 3x, I get 4x. I'm subtracting 14, I get negative 15. And then I'm going to divide by 4 on both sides. So I get x is equal to negative 15 over 4. Okay, so this is good. It's not one of my exclusions, so I don't have to worry about it. And then I'm just going to check and see if I get the correct answer. So I want to check 3 times negative 15 over 4 minus 1 over negative 15 over 4 plus 2, and I want to see if that's equal to 7. Okay, here I would suggest plugging into a calculator if you want, or if you're good at mental math, you could also do that. I'm going to pause the video for a second, so it's going to blurt back on once I've done sort of that arithmetic. So if you want to pause and see if you can check it at this point too. Okay, so I multiplied and I got negative 45 over 4. I rewrote my 1 as 4 over 4. In the denominator, I rewrote my 2 as 8 over 4. So I ended up with negative 49 over 4 and negative 7 over 4. So I knew the 4's were going to divide out. So I was left with negative 49 over negative 7, which is 7. So that shows I have the correct answer. So this would be my answer right here. So at this point, pause the video and try the you try problem. Okay, so again, I found, hopefully you got the same answer, 7/4. I knew that x couldn't be 4. I did cross multiplying, negative 3x, negative 3 times negative 4 was positive 12, 1 times 5x minus 2 was 5x minus 2. I moved all my x to the right. I divided by the coefficient, I got 7/4, and then I did a check here, so I'm confident that my answer of 7/4 is correct. Okay, so our next one looks a little bit more complicated. One of the things, but it really is the same process. Okay, so we're going to multiply 3 times the quantity x plus 4, so that gives us 3x plus 12. We're distributing that 3, and then 1 times the x squared plus 4x gives us x squared plus 4x. Okay, looking at this, I now see that I have a quadratic equation. So anytime I have a quadratic equation, I want to get 0 on one side and my quadratic on the other. So I'm going to move the 3x and the 12 to the right, so this becomes 0. X squared stays the same. 4x minus this 3x is plus x, and minus 12. Okay, so I'm going to check and see if I can factor this. Do I have two numbers that multiply to negative 12 and add to 1? For me, that's x plus 4, x minus 3. So I'm just checking real quick. X times x is the x squared, 4 times negative 3 is the negative 12, and then 4x minus 3x is the x. So this would give me the answer of x equals negative 4 and x equals 3. Okay, but notice if we put negative 4 into our original equation, it's going to cause division by 0. So we call this an extraneous solution. So we want to put a line through it like this with an arrow. This is how we show extraneous solutions. And on your answer sheet, if it said to put the answer on the line, this is exactly how you would want to show it. You still want to show it as an answer, but the line through shows that it's extraneous. It shows that it makes the equation undefined. Okay, so now if I plug in 3 real quick, I'm going to get 9 plus 12, that's not 0. 3 plus 4, that's not 0. So now I'm going to check my number 3. So I'm going to have 3 over 9 plus 12, and I want to see if that's the same as 1 over 3 plus 4. So just doing some mental math, this would be 3 over 21. This would be 1 over 7. you don't have to write down as far as you realize it's true. So if you realized it was true at this point, you can end there. If you could do it as mental math, that's fine, but you do want to be checking these. So my answer of 3 is correct. So I'm just gonna mark this as my answers. You want to give the extraneous solution and then the solution that makes the equation true. So pause the video now and try the you try problem. Okay, so I cross multiplied 2x squared minus 2, and then if you could go right to the next line, that's fine, but I did put what this looks like multiplied for people as they're just learning it. Then I expanded here. I moved everything to the left side so that my right side is 0. I factored. I found the solutions were x equals -4 and x equals -1. I eventually found out that the x equals -1 was extraneous, but first I checked x equals -4. Okay, I got this fraction and I used cross products again. 2 times 15 is 30, -3 times -10 is 30. So since 30 equals 30, I know that x equals -4 checks. When I went to put in x equals -1, I immediately saw that it made the first expression undefined, so I marked that as extraneous. Okay, if you have any questions about this, please bring them to our next class.